Calc BC, we're looking at problem 16, the last problem in our station's activity. So we're given the graph of f prime. We're also told a value f of -2 happens to equal 7. We're told that our function f, which is not pictured, is in fact differentiable. The derivative always exists. So we've got a semicircle, 3 line segments. We're trying to see if we can find the values of f of -6 and f of 5. These are one of the most frequently asked questions, so it's good to break this down. I guess what I really want to tell you is, as we're looking at this problem here, we can most definitely see that we are told something about x equals -2, and yet we're trying to find f of -6. So I'm going to set up an integral from -6 to -2. And the reason why is I'm told something about x equals -2, and I'm looking for f of -6, and I'm going to integrate f prime right here. So here's what we need to be aware of. This integral does in fact represent net area. It truly does. And we can find that net area quickly. Here's, from -6, here's -2. I think it's going to become abundantly obvious that we can do this with geometry. We've got a nice little triangle here. That being said, as we're looking at this, there's more than one way to look at this integral. We can go ahead and take an antiderivative. We can get f of x evaluated from -2 to -6. Look at this. This is f of -2 minus f of -6. Why is that so helpful? With the fundamental theorem, I was told something about f of -2. I'm told that that is 7, and I am looking for f of -6. So I'm able to find that pretty quickly. Now, my net area, when I look at this from -6 to -2, that, of course, is a base of 4. It's 4 steps from -6 to -2. Having a height of 2 here, we can say 1/2 base times height, and that's just a 4. And it does not take too long to go ahead and solve. I can subtract a 7. 4 minus 7 is -3. And then we can divide out a -1. And you can see f of -6 is actually going to equal a 3. So, hey, we've got that much going. So you might not be too surprised to see that the next part, going up to x equals 5, is amazingly similar. What we do now is continuing. I'm just going to integrate now from -2. You might think, well, why are we doing that? I'm given information about it. But this time I'm going to go up to 5 because that's what I'm looking for. So at this point, I could do the fundamental theorem. I could say my antiderivative is f of x, and I'm going to plug in my 5. I'm going to plug in my -2, and I'm looking for that f of 5. We're going to get to that in just a moment. But the f of -2, they told me in the beginning, that's what I circled, that's 7. So now what? Well, all we have to do is revisit and see if we can get our net area. Going from -2 all the way up to 2 is a semicircle. And then going from 2 to 5, I think you can see right here, is a triangle. So, with this semicircle, I'll tell you what, I'll even erase this portion just to have a little bit of space. For a semicircle, we know we're going to have 1/2 pi radius squared. Your radius, I hope you can see, is 2. And that's going to be 1/2 of 4, which is 2. So that's a 2 pi, but guys, that's going to be a -2 pi. because it's below the x-axis. Then I've got my blue triangle here, and I'm going from 2 to 5. Well, what's the distance from 2 to 5? We can subtract. 5 minus 2 is 3. So my base is 3. My height is a 2. So the area of this triangle, I'm going to go 1/2, base of 3, height of 2. That's just going to be a 3. So this is a positive 3 at that. So we've got negative 2 pi plus a 3. And then you can add a 7 as you're solving. And you could have f of 5. Well, 3 plus 7 is a 10. And I can write that as 10 minus 2 pi. So that's what f of 5 is all about. That's what we have there. 10 minus 2 pi, or negative 2 pi plus 10. But then what? They want to know when f is increasing. Well, thankfully, this is a little bit easier of a problem. You don't have to calculate as much. You just have to know your definitions. F is increasing when f prime of x is greater than 0. So you have to ask yourself, when is f prime of x greater than 0? Well, it's whenever f prime, which is what we have here, is above the x-axis. So plain and simple, it's that. You can see where we're going. We're going to say that for part B, f is increasing, and we're going to use closed intervals. We're going to go -6 to -2. Union that with, well, this would be from a 2 to a 5. But they want you to justify, which is such a good practice to get into. The reason why that is true is we could say because f prime of x is greater than 0. And that is the end of our station activities.